So right now that we are done designing our circuit, the next thing is to prepare it for PCB development. Is that okay? But then before we do that, we have to make sure that there are no errors with our circuit. Now, KiCAD has some tools here that have been arranged sequentially, also showing you that you should do them step by step. Is that okay? So let's go through these tools and then make our circuit ready for PCB. So these tools that I'm talking about are what we have between these lines here. Okay, this five, I think six tools. Okay, so the first one is annotation. Annotation is a way of assigning specific references to each component. Each component has to have a unique reference, and by reference I'm talking about this J1, SW1. So you can see that there are two connectors. Connectors are designated with J, right? So if I have many connectors, let's say 5, then the first one is going to be J1, the second one is going to be J2, in that order up to J5. Okay, now if I click on this, currently the new versions of KiCAD automatically handles that as you add the component, but earlier I think version 5 wasn't doing that, right? So for instance, let me clear the annotations. Once I clear the annotations, you realize that now instead of J1 it has become J question mark, right? And we also have J question mark. This means that these things are not uniquely identified, meaning that it will be difficult for KiCAD to work with them. Is that okay? So when we run annotation, it's just to assign specific or unique references to this component. Is that okay? Now you can decide to do it manually yourself, or you can if you want to do it manually, you can just double click on the thing and then set the value that you want, right? But that is boring. You don't want to do that. So you can rather click on this annotation tool and ask KiCAD to annotate it for you, and KiCAD will go through every component and assign it a unique reference. Is that okay? Now after annotation, the next thing that we need to do is to check for errors in our circuit. The errors usually is going to be about connectivity, because schematic is about connectivity. So if we click on the next one here, we call it the electrical rule checker. All we have to do is to run ERC, and you can see that it reports that we don't have any errors and we don't have any warnings. Now earlier I said that when a pin is not, you are not going to connect a particular pin, right? You should put that no connection flag on it. And why is that necessary? Now let's try and run the electrical rule checker again, and this time around we will get one error, and the error says that pin not connected, right? Now this particular thing has saved my circuit so many times, because there are times where the pin was supposed to be connected, you just forgot to connect them, or you had done the connection but it wasn't properly connected, and by just inspection you couldn't find out that thing wasn't properly connected. But when you run this electrical rule checker, it is going to identify those things for you, okay? So that in case you deliberately don't want that pin to be connected, then the way you do that is to put the no flag symbol on it. This will tell KiCAD that yes, I'm aware that this is not connected, so don't draw my attention to it. And right now, if we run the DRC again, you realize that we don't have errors anymore. So once we don't have any errors, then it means that in terms of connectivity, everything is right. But take note that this DRC does not have a way of telling you that you have connected a component wrongly or not. Is that okay? It doesn't have any means of telling you that. At best, it can tell you that, okay, you connected the power to power and it's not a good thing to do. But it can't tell you if, for instance, instead of connecting pin 3 and 2 to ground, I rather connect it to the battery and connect pin 1 to ground. KiCAD, the electrical rule checker, does not have any way, or does not have any means of letting me know that I've made that mistake. It can only tell you that, okay, there is no connection here and those kind of stuff. Okay, so now once we are done, the next thing is to run simulation, right? But then if you want to run simulations in KiCAD, then right from the start, at the point you are building your circuit, you should be choosing components that have simulation models. Okay, but that wasn't the purpose of what we are doing, so we never chose any component with a simulation model. So that means we will not be doing any simulation, so we'll forget about this. But the one important thing that you need to do now, if I click on any of these components, if you check down here under the footprint segment, you see that footprint is unknown. If I click on the switch, footprint is unknown. If I click on the resistor, footprint is unknown. If I click on the lamp, footprint is unknown. So basically we cannot create PCB for this work because there are no footprints assigned to the component, right? So the next thing that we need to do is to assign footprints to the component. We can do that by clicking on this footprint assignment tool. Once we click on this footprint assignment tool, it will bring all the components in our schematic, and you can see that none of them has a footprint assigned. Okay, so our duty here is to ensure that we have assigned them footprint. The footprint is like how the pins will be, how the connection will be on the board, or where the physical connection, how the physical device will be connected. Okay, that's basically the footprint. So now what we have to do is to select the component, one component after the other, and assign those footprints. So let's start with the first component, J1. J1 is the power input, right? And we said we wanted to use a DC barrel. Now, a DC barrel, so in the schematic, the component we chose had 3 pins. That means whatever footprint we choose should also have 3 pins, right? So DC barrel is a connector. So once we look through the component, the libraries and the connector, so you can see connector, barrel jack, right? So if we click on it, then with these filters here, we can actually filter out the footprint. So look, if I uncheck everything, it basically brings me everything in the libraries, those that I need, those that I don't want. So when you see that unnecessary things are popping up here, just come here and toggle this these filters, right? So once I toggle the filters, you see that everything that I have right now is a type of DC barrel jack, right? But then right now, how do we get to know that this is the right one that we are choosing? Okay, so the way you do that is by bringing up what we call the footprint viewer. Okay, so we will bring up the footprint viewer. So this is the icon you use to invoke that. Once I click on this icon, it will bring up my footprint viewer. So now if I click on any of this, I will see how it's physically, how it's formed. I'll see how it looks like. And even better, if I want to see a 3D view of it, I can click on this icon here, and that also bring the 3D viewer. Okay, so now if I select any component and it has a 3D, so if I select any footprint and there is an associated 3D like this, see, I can see that, okay, this is how it looks like, and this is how the one I have also looks like. Okay, now basically the components that we want, this DC barrel that we want, is actually having this footprint. Now how do I know that? You can always check for your component from where you are buying it. If you are probably getting it, let's say from a store, an online store, then chances are that that online store has actually put information about that component, right? So for instance, if you want to buy the component from AliExpress, okay, we just have to search for DC barrel, and this is actually what we are looking for, exactly what we are looking for. Okay, it's a 5.5 times 2.1 mm barrel jack. Okay, so once that we know that this is how it looks like, and please take note of the pins, how the pins are arranged. We go back to the KiCAD, and then you can see that basically that is the footprint. But unfortunately, we don't have a 3D model, right? But what really matters is the footprint, not the 3D model. Okay, so since this is what we want, we can select it, okay, like that. You can just double click on it and it gets selected. Now we go to the next component, which is the lamp. The lamp, we said we wanted to use a screw terminal block, right? So again, we can go online to where where we are getting our component from and search Um, Now this terminal block has a pitch of 5 mm, right? So you can say type something like screw terminal block, okay, 5p or 5 mm, okay. Now how do I know what to set? Is because I have used this component. Now from this I know that this is something that I want. I need something with 2 pins, right? So you can see that over here they have some with 2 pins and they also have some with 3 pins. So I'm looking for a 2-pin terminal block. Okay, so something like this. Okay, and the most important thing is that the space between the pins should be 5 mm. Now the space between the pins, as I said, is what we call the pitch. Is that okay? So let's go to our connectors once again. We want terminal block, right? So we search for screw terminal block. So let's scroll down, terminal block. So you can see that we have various types of terminal blocks here. So let's select this guy, and you can see that right from the word go, we have one by bond. We have one here with a pitch of 5.08 terminal spacing, which is exactly what we want, right? But then it doesn't have a 3D model, so it's not very interesting for us, but that is basically what we want. So let's see if there are other things that we can use. So you can see that this is also a terminal block, but this one has a pitch of 3.5, so that's not what we are looking for. Let's go to these guys. Nothing here. Wago, nope, not this. So you can search through until you are okay with what you are looking for. Okay, so this one too has a pitch of 5, so we could use this, but it's actually not what we are looking for. Oh, fantastic! So we have some with what do we call it, 3D models. So let's see if we would be lucky to get the pitch that we want. Unfortunately, oh okay, so fortunately we just got one, right? You can see that the pitch is 5.8 as we want, and it is 2 pins, so we can select that terminal block. Okay, right, now we go to the resistor. The resistor, as we calculated, is supposed to be 3 ohms. But what is important when you are choosing the footprint is the wattage, right? Now, earlier we said that what we calculated, the watt was supposed to be 3 watts, but I said that for design sake, right, we are going to double that value and choose something around 5 watt or 6 watt, okay, so that it can withstand the heat. Is that okay? So this kind of resistors are normally come in the form of what we call power resistors or cement resistors. Okay, so we can go online and also search for them like we did for the rest of the components. So when we come to AliExpress, for instance, we can search for 5 watt resistors, and what we are looking for actually looks like this. Okay, so at this point you should know the component. Okay, you should know. If you don't know about the component, read about it, check it data sheet, know its dimensions, because the moment you fail to do this, problem for you. So over here you can see that we have 5 watts, 5% tolerance, and so I explained earlier that tolerance is how much it deviates from the rated value. So 5% tolerance is not bad. Okay, and then you have a whole lot of different values to choose from. For us, we need a 3 ohm resistor that is 5 watts. Okay, so basically that. Now the next thing is to look for the dimensions. Okay, so on AliExpress usually the stores don't put these details. Now there are some stores that you will be lucky to get these details, but not all of them. So if you scroll down, you can see that we don't have any dimension, right? We have information on the power rating. Okay, there is view more. Let's see if we have dimensions. Unfortunately, no, we don't have any dimensions. Okay, great. So we may have to go and search online. Okay, so we can come to Google and search for 5 watt cement resistor, and this is actually what we are looking for. Okay, and you see that here we have the dimension. So the width without the pins is 22 mm, the height is 9.5 mm, the length is 22 mm, the height is 9.5, and the width is also 9.5. So this is basically what we are looking for, and that is actually what we are buying in case we pay for this. Okay, so now we have to come to our KiCAD, select our resistors. Okay, and that resistors, we have to drill a hole to push them through. So any component that requires that we drill a hole to solder them into the board, we call them through holes. So when we come to the footprint selection, we will look for resistors under the R section. So you see that here we have resistors SMD. Resistors, the SMD stands for surface mount device. Then we have resistors through hole. So we are looking for through hole, something that has to go through a drilled hole, right? Good. And we are basically looking for the type, the cement resistor type. So they are usually called power resistors. Okay, so if I click on this, yes, they look like this, but this one is too big or too long than what we want. Now what we want has a length of 22. So if we add the part of the where the pins have to go into, then we should get something around 25, right? And it also has a width of 9. Like on the thing we had 9.5, right? And so 9.5, that is okay. And the pitch is 27, so the pitch for this is 27. So basically this is what we are looking for. So we select it and we assign it, right? Now the last part is the switch. The last part is the switch. Now when you are choosing the switch, you should be mindful, because every switch and the amount of current it can handle. Fortunately, we are only switching 1 amp. Okay, so most of the switches that we can get can work for 1 amp. Okay, so let's go and select a switch. We need a switch that has the form of a toggle. Okay, so we can come back to the footprint editor and look for switch. So we are looking for a switch. All right, so we have we should have a switch. Switches. Where are you? Sometimes they come under different names. Okay, so I think we have some button switches here, right, through hole. So you have button switches through hole. So let's check them out. Okay, so this could work, right, but this is not what we want to use. You can see this one too. So this is also a switch that we can use, but we don't want to use this. This is also another, but we don't want it. Okay, we could also we could get this in the market, but we don't want this. Let's see something that is easy to use. No 3D model. Let's see if we can get something to rocket switch. I know there should be, because I've seen different types of switches out there. So sometimes if you can't find a thing, you could also search for it. Oh, okay, here there is no search. Oh, there should be switch. There should be a switch. Button switches. No. Okay, now I'm going to show you one more trick. Whenever I find it difficult locating a component, a footprint from this side, what I do is, yes, so I apply, although I haven't set the component for the switch, yes, I'll apply it and then set OK, right? So now if I click on the barrel, you see that we have a footprint connected, we have a footprint assigned. If I click on resistor, we have a footprint assigned. If I click on the lamp, we have a footprint assigned. But right now, only our switch, we don't have a footprint, right? So aside launching the running the footprint assignment tool, you can actually do that manually. So if I right click on this, I can go to assign footprint. You can do that with F actually. So I think over here we can access it through the properties. So we can go to properties, and over here we get the chance to assign footprint, right? Now usually when I go through this point, I'm able to load more libraries. I don't know why that happens, but it does happen. So here to see that I have the chance to search, right? So I can now type for switch and see we have so many things coming up. Button switch. You can see that this time around we have many things under the button switch. Okay, so let's go through it. Of course, let's bring up the footprint, the 3D model, so that you see what we are looking for. Where is my 3D? Oh, where is my 3D thingy? All right, let me bring it up. Yes. Okay, I don't know why it is hiding. All right, so just the same thing. If I click on this and press F, it will ask me to select a footprint, and let me do that way. Bring up my 3D. Good. So we are looking for a switch. So now we can go through this and see. So these ones are push buttons. We want something that latches, right? So these are good. If we see one, I will actually identify it. Else you just go and choose one of the previous ones. There is a particular switch that I'm looking for. Well, like I said, we could say that we are using this one. So I think for simplicity, let's just select this one. Okay, it is definitely a latching switch, and I think it could handle the currents. But then, so let's take note of the name SWNKK, right? So we'll come back to it if we don't get anything interesting. This one too could work. These are all DIP switches. We don't want DIP switches. So let us also run through and see if we can be lucky to find another thing. So switch. All right, so technically I'm not seeing anything. So usually it could also be that those things are there, but they have specific names, and that's not what we are looking for. Okay, so yes, let's go back to our NKK, and that is what we are going to choose. So we are going to choose our NKK switch here. Unfortunately, it also has a 3D model. That is a good thing. So we can, this is also another way we can assign footprint. Okay, so if for instance you have assigned footprint already to the rest of the components, you are just left with one, then you don't have to waste your time going through this. You can just select that one and assign the footprint. Okay, so now we have assigned footprints to every component in this. That means we are ready to design the PCB. Is that okay? Now at this point there is one last thing you have to do, which is to bulk edit your, if in case for instance you are going to order your component from China or from any online shop, right? Then you need to generate something we call bill of material, right? So if you click on this boom tool, it will bring you the component that you are using, right? And then you can filter them. So usually I want to keep my footprint and the values. Okay, so you see it says that we are using this, and this is the, so here I can actually adjust the name and use the name that the seller uses, right? Or I could actually add the field. Okay, so let's say if this particular component has a special name that the seller uses, I can add that field and it will be added to it. Okay, then I can export it as a CSV and send it to my component supplier. Is that okay? All right, and then finally you can, oh okay, so this is actually where we generate the bill of material. This is where you do a bulk edit of all your symbols. So if you want to generate your bill of material, here you have a lot of scripts that can nicely generate your bill of materials in whatever format that you want. Okay, all right, so I'm not going to do that right now because that's not something we need at the moment. So now that we are done, the next thing is to now ship or export the work to the PCB editor so that we can lay out the PCB. Now, how do we do that? You do that by going to tools, and you select update PCB from schematic. I'm taking it again. You select tools, and then you hit on update PCB from schematics. So once I click on this, KiCAD will automatically package all these things, the circuits and their connection and their footprint that I've assigned, and send them to the footprint editor for me. Is that okay? So you can see that the process is ongoing at the moment. Okay, so at this point it means that we are ready to design the PCB for our work. Okay, so I'll pause here briefly and take questions. Then afterwards I'll just take a little bit of your time to at least do the PCB quickly. Then you guys can go and practice, right? So any questions?